Okay, welcome ladies and gentlemen, and we're looking at the first lesson of chapter 2 in your grade 11 math course. And we're looking at your workbook pages. We're starting on 67, and I'm going to go all the way up until 71, I guess. So 67 all the way up into 71. So you can pause now and make sure you get out what you need, and then you can start this up again. Okay, so I wrote this, therefore it must be important, therefore we might as well read it. The roots, now that's a word that you need to know, the roots of a quadratic equation in the form ax squared plus bx plus c equals 0 can sometimes be found by factoring and solving for each of the variables in the factor. The roots of a quadratic equation in the form ax squared plus bx plus c equals 0 can always, now there's a big difference between always and sometimes, using the quadratic formula, which is x equals, so the root is x equals, and it would be a number, so it's x equals negative b plus or minus square root b squared minus 4ac over 2a, and you just have to know that. Okay, get it tattooed on your arm or whatever, but you've got to know that inside out. A quadratic must be expressed in standard form. Standard form is ax squared plus bx plus c equals 0. All of that needs to be done. And if you want to make your life more convenient, then you're going to make sure that 8 is always greater than or equal to 0. So you're going to make sure that a is a positive number. And if it's not, then you're going to move everything into the other side, changing this to positive, changing the signs here, but you'll still have it equal to 0. So a quadratic must be expressed in standard form before, that is so important, I'm using another color, before it can be solved either by factoring or using the quadratic formula. So either case, we got to put it in this form first, okay? Not in this form. If it's not equal to 0, we can't be doing either one of these. And these are different. One is by factoring, and one is using the quadratic formula. The quadratic formula sometimes leads to a negative number under the square root sign. Ooh, negative number. When this happens, the quadratic is said to have no real roots, meaning no roots from the real number system, but instead it has two, I don't want to say imaginary roots, we're going to say complex. That's a mistake on my part. It has two complex roots, not imaginary roots, okay? So it has two complex roots, and that means that the roots are going to come from the complex number system. Okay, so let's take a look down here. The difference here, just before I go on, a complex number, as we've discussed in class, is any number in that form where a and b are elements of the real number system. So following that, 7, the number 7 is a complex number, 7 plus 0, I. Now, an imaginary number is one that has only this part to it, okay? So this has a real number part, and this has an imaginary part. So a completely imaginary number would be something like 3i. And as you know, that came from 3 times negative square root, the square root of negative 1, which is the square root of negative 3. So 3i is equal to the square root of negative 3, but we prefer to write it like this. And we've had a lesson on that, and if you're a little bit confused on that, go back over your complex number system, and it's a couple of posts ahead of this one. So, solve by factoring. So it's telling me here in example 1, all of these need to be solved by factoring. So it's a trinomial. It goes x squared x without any x's. So it's going to be an x. It's going to be an x. Two numbers that multiply to give 15, add to give 2, 5 and 3. They multiply to give a negative, so one's positive, one's negative. They add to give a positive, so the larger one is positive. So what I did was I took that part and I factored it, and it's still equal to 0. This is the 0 principle. I've got two things that multiply to give 0. That means either the first one is 0 or the second one is 0. So if x equals negative 5, I'll get negative 5 here plus 5 is 0. I'd get negative 5, negative 3, I get negative 8. I'd get 0 times negative 8 is 0. It works. If x equals 3, I'll get positive 8 here, and I'll get 3 minus 3, which is 0. So I'll get 8 times 0, which is 0, and it works. So to solve the values of x that allow the left-hand side to equal the right-hand side are x equals negative 5 and x equals 3. That's it. That's all she wrote. This one, it's not in standard form. 2x squared minus 7x plus 3 equals 0. You must do this first. This is a must. No maybes, no kind of, but a must. Looking for two numbers that are going to multiply to give me 6. Now, again, I like my factoring to be done off-site. I don't want to see it. So it's going to be a 2 and an x, a 2 and an x over top of 2. This is what we call that hard trinomial. So two numbers that multiply to give 6, I had to give 7. How about 6 and 1? They multiply to give a positive, so they're either both positive or they're both negative. They add together to give negative. This 2 has to come out of this one, or a bit of both. It's going to come out of this one. Check it to make sure you're right. X times 2x is 2x squared. X times negative 1, negative 6x will be negative 7x. Positive 3, it works. So this is going to be x minus 3, 2x minus 1 equals 0. Okay? So you must get it equal to 0 first. Then you can factor it. And now, you've got two things that multiply to give 0. So either the first one equals 0, or the second one equals 0. I might have jumped a step here for you. You can put them in, but I'm going to leave it out, and that's how I would want to see it solved in the very least. If you want to put in a couple of extra lines, you can too. Moving on. Take a look at this one. I'm going to solve that by factoring. I must put it in this form. It's not a trinomial. However, we can common factor. Seven x times x plus 2. I've got two things that multiply to give 0. So either the first one's got to be 0 or the second one's got to be 0. Divide both sides by 7. Or notice that when we do this, these are equal signs, not cannot equal, because we're not worried about the denominators. What I would like to say to this, just while we're here, is let's say you tried to do this a little bit differently. Let's say you divided both sides by x and a 7. You would be left with x equals negative 2. Do you agree? Notice that that was one of the answers we got here. But notice we lost an answer. X equals 0 is also an answer, and we didn't get it here. You want to know why you didn't get it? Because you divided both sides by a variable. And when you divide both sides by a variable, you're putting in a restriction. X cannot equal 0. The restriction is there because of how you solved it, not because of the original question. The original question doesn't have a denominator. It's fine, but because you divided both sides by 7x, or more importantly, the x, you invented a restriction where x cannot equal 0. But it is one of our answers. So in other words, this method stinks. Solving by factoring, much better. Okay, next one. Again, I want to put it in standard form. I want it to look like ax squared plus bx plus c equals 0. Now in this case, my variable is going to be a's. Okay, and my numbers are going to be a, b, c. But my variable is going to be a in this one. So this is what I want. So what I'm going to do is I'm going to get rid of the fractions. I'm going to multiply each and everything by the lowest common denominator, which is 2a. So I'm going to multiply the first 2a by 2a. I'm going to multiply the 5 over 2 by 2a. And I'm going to multiply the 3 over a by 2a. Now, this guy, and this guy all came from the original. Okay, oops, let me move it over. You're missing that. So this guy, and this guy all came from the original question. And this 2a is what I'm multiplying both sides of the equal sign by. So in essence, I'm not changing anything. So this becomes 4a squared. The 2's reduced, leaving me with plus 5a. The a's reduced, leaving me with 6. Now you're going to say, but you just introduced a restriction. A cannot equal 0. But it was a restriction that already was there. I already had a restriction here of a in the denominator, so it's no big deal. A cannot equal 0 from the question, not just because of what I did. Okay, so what do we got here? I'm still not in standard form. That is standard form. I need it to be equal to 0. Without being equal to 0, I cannot do anything. Okay, so now I'm going to factor that, and I'm going to do it off to the side. So it's going to be 4a over 4. Two numbers that multiply to give 4 times 6 is 32. So 1 and 32, 2 and 16, 3 and I don't know, so I'm going to grab a calculator. So I do 32 divided by 3, and I get, doesn't go evenly. So 32 divided by 4 is going to be 8. Hold on a second, I want them to add up to 5. Have I hit it yet? Doesn't look like it. 32 divided by 5 won't go evenly. What about 32 divided by 6? Ooh, not evenly. What about 32 divided by 7? Not evenly. 32 divided by 8 will get me back to 4. So looking at this, hold on, unless I've made a mistake. I want two numbers that multiply to give 16, and 16 is 32, add to give 5. It's going to be, did I do this right? That's a 5, that's a 4, that's fine, okay. So, blah, 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 4 and 8, it doesn't factor. That cannot be done by factoring. That's going to have to be done using the quadratic formula, but it can. I must have made a mistake here. This is, let me look at this one more time. Multiply by 2a, multiply by 2a, multiply by 2a. 2 and 2 is 4a squared. They'll reduce, giving me positive 5a. They'll reduce, giving me 6. Take it over. Maybe I'm making a mistake. What is 4 times 6? 24. Ta! All right. That'll get you. So 4 times 6 is 24. So I'm looking at 4a. 4a. Oh, that's ugly. Sorry for the long video, just to finish this off. So I got 4a squared plus 5a minus 6 equals 0. So I need to factor this. I'm going to get 4a over 4. 4 times 6 is 24, not 32. 1 and 24, 2 and 12, 3 and 8. That'll do it. That'll give me the 5. So 3 and an 8. They multiply to give a negative, so one's positive, one's negative. They multiply to give a positive, so the larger one's positive. The 4 is going to come out either of here or of here, a little bit of both. It can come out of here. So it's going to be 4a minus 3. Common factor out the 4. A plus 2. Goodbye. That's going to leave us with 4a minus 3. A plus 2. Let's make sure that it makes sense. I'm going to expand it. And what I'll get is 4a times a is 4a squared. 8a, take away 3a, is 5a minus 6. It works. So this is 4a minus 3, a plus 2 equals 0. Therefore, either Yeah, you should write it. A equals 3 over 4 and or A equals -2. You can't see it. So either A equals 3 over 4 or A equals -2. And those are your two answers for that one. Okay, I'm going to stop this here and we'll come back with the other side.